Hello my dear students, I am B S Pandey, your physics lecturer. My dear students, today we are in lecture number 72 of standard 12 and we are going to start today a new chapter. It is alternating current, that is the AC. Okay, so look at here, we are today in new chapter. It is lecture number 72. And NCERT chapter number, it is 7. This is alternating current AC. My dear students, in last chapter that we study about the electromagnetic induction, we have started the concept of alternating current. I hope you remember the induced EMF, induced current in any coil. We will start this particular chapter from that topic. Okay, here our topic, the first topic, it is production of AC. Whenever we talk about the alternating current, that is the AC, this is the alternating current. My dear students, we will study in this entire chapter about the two things, and it is the alternating current and alternating voltage. Alright, alternating current and alternating voltage. We will represent this alternating current by I and the alternating current voltage by E. That two things we will study. We will study the different form of this alternating current and voltage in this chapter. But when we talk about the alternating current, it means the something quantity which changes alternatively. That's why it is known as the alternating. Okay, and this is written as AC current. The full name, it is alternating current. Okay, it is alternating current, and AC voltage, it means alternating AC voltage, it means alternating current voltage. Okay, current, it means the flow, and voltage, it is referred to the potential, and electric current, it refers to the flow of charge, the rate flow of charge. Okay, now let me discuss. We start this chapter with the production of AC, how this AC produce. So the first topic, you will write production of alternating current, or the production of AC quantities. We will study the source of AC in this chapter at the voltage or the current generator, AC and DC generator both. Okay, that is the source of alternating current and voltage. But how that generator will produce the electric current or the voltage, we are going to study here, and we are starting this chapter with the production of AC quantities. Suppose we are having a coil having the n number of turns. So having n number of turns, you can write, okay, this is the axis of the coil, but this is placed in uniform magnetic field. Okay, this is the uniform magnetic field. At an instant, this coil is allowed to rotate with angular velocity omega, that is the angular frequency as well, you can see. At certain time, the area will be in this direction, but if you give some time, t second, this coil rotate, and due to rotation, there will be change in flux. The maximum flux you can consider Remember, we are going to that chapter. It is the electromagnetic induction. Going to recall, if this coil is in this condition, the maximum flux trapped by this coil. As it will move like this way, the flux decreases. And in this case, the flux will be zero. No field lines will be trapped by this very thin area. It means as it will rotate inside this magnetic field in this way, there will be change in flux continuously. Flux will be maximum to 0 and 0 to maximum and maximum to 0 after each rotation. We will study in very detail when we will study about the generator, AC generator. Look at here. If the area vector rotated in this time t second by an angle theta, so we can write thus theta is the angular shift, that is the displacement, which is nothing but the omega into t. What is this omega, my dear students? Remember, this omega can be written as 2 pi f, where f is linear frequency. Linear frequency. In our India, in our country, this value of linear frequency of AC, it is 50 Hertz. Okay? However, this theta can be written as omega t. Now, the flux can be written as this flux. We know that B A cos theta. And here we can write the B, that is the uniform magnetic field in which this coil is kept. It is B magnitude. Area vector, it is A, and cosine theta for any time t, the instantaneous value will give you omega t. Remember, this flux is not the constant or the maximum or the minimum, but this is the instantaneous flux at any time t second. Now, we know that according to Faraday law, of electromagnetic induction, that E induced, it is minus d phi over dt. Which type of flux it is? Magnetic flux, and this is the function of time. Now, by differentiating this flux, we will have B A cos omega t over dt will have the induced EMF. Okay? Now, we can write here this BA are constant taken out. Alright? BA constant, and then we will have here d cos omega t over dt. I hope you understand. Now, we can differentiate this value like this way: minus BA, it is induced, minus BA, and cos omega t will be integrated for the sine value, but it is how much? Sine omega t, and the integration differentiation of cosine will be the minus sine, it is the minus minus plus, so the sine omega t over omega. Okay, sorry, the differentiation, it is the multiplication of this quantity omega. Now, if there will be the n number of terms, then flux, you can see over here, the flux can be written as the n times. So you can multiply all the quantities with the n. Here n you can include, n will be out, it is constant. So this E induced is nothing but it is n A B omega sine omega t. Now you can see what are constant and what are the quantities that are changing. Here n number of turns not going to be changed. How many turns it is taking, it doesn't matter. Cross-sectional area, the area of the coil is not going to be changed. B, magnetic field, it is uniform. Omega, it is constant. It means this all value are constant, and this will be maximum to this value only and only if this will be how much? 1. We know that this particular value will vary from -1 to +1. It means the maximum value of this E induced will be NAB omega, and the minimum it will be the minus NAB omega. For maximum value, this is also called peak value. Remember, the sine omega t should be how much? It is 1. And if it is 1, then E max will be NAB omega. This E max is used to represent by E naught. In our derivation, we will represent by E naught. Okay, now the next. We are going to find here the relation. It is with the instantaneous value and the EMF. Okay, so look at here. Now we can write this instantaneous value, this E induced, ET, can be written as E naught. The entire value can be written as the E naught, and then sine omega t. And this is the instantaneous voltage, but this is alternating voltage. If R is the resistance of that coil which was rotating, then we can write I instantaneous, it is E instantaneous divided by R, and it is nothing but E naught by R sine omega t. Since it is the maximum value, E naught divided by R, and this is the constant, so this will give you IT as, this is I naught, this will be I naught and sine omega t. When we consider the resistance of the coil as R, then this will be the instantaneous current, and this is called the alternating current. We will try to see this particular thing over the graph as well, but this one is very important, my dear students, to think. Thus IT is equals to I naught sine omega t, ET, E naught sine omega t, where I naught is the peak value of current. Let me write again. It is the peak value of current, as this is the peak value of voltage. Peak value of voltage over EMF. Now we are going to represent this one over the graph. Okay, so I hope you can understand the graph of this quantity. The equation, it is I naught sine omega t and E naught sine omega t will give you the graph. IT, it was I naught sine omega t, and ET, it was E naught sine omega t. One thing, my dear students, for which value the amplitude will be maximum, for current or voltage. Look at here carefully. This IT is E naught by R sin omega t. We have written, I hope you remember. It means the amplitude of E naught will be greater because the amplitude of I naught is 1 by R times. So the amplitude of E naught, you can write, will be greater than the amplitude of I naught. It will be helpful to draw the graph. Now I am going to represent over this graph. Suppose the maximum value will represent for the current and then for the voltage as well. If this is the peak value of voltage E naught and this is the peak value minus E naught and this is the I naught and minus I naught, so we can draw the graph. You must be careful while drawing the graph. You have to study one quantity that will be studied as the phasor diagram. We will study later on. But here, the graph of current, it will goes with the sine omega t, and for the voltage, it will also goes with the sine omega t. It means the maximum value of ET and IT will be at the same angle, and the minimum value and the zero value as well. So this is the graph. Since it is the graph of sine, that's why I am starting from the origin. This looks like. Now, graph for voltage, it will be, looks like this way. You can see the max zero at the same angle, the maximum at the same angle. Again, the zero at the same angle and the maximum at opposite direction will be at same angle. So this will be the graph of alternating current and voltage. This red one representing ET, whereas this black one representing IT, the instantaneous current, and this is the instantaneous voltage. Okay, so we have discussed. Now my dear students, if I'll give you the graph, certain graph, then I hope you can find out which one is alternating current and voltage and which are direct current or voltage. So some graphs are here. Suppose you have to just tell me which one is AC and which one is DC. This axis representing the omega t or the time period, A, B, IT, this is omega t, C, this is IT, omega t, and D, now my dear students, you have to guess which one is AC and which one is representing DC. Think over it, pause the video and think over it. So did you got the answer? Now look at here. Of course this is AC. Why? You can see it is changing its value alternatively from positive to negative. Here also you can see it is going positive and negative for a particular cycle. Okay, but here you can see the amplitude, of course it is changing, but you can see this is not changing its direction. That's why this is DC current. We will study a device that will be considered as the rectifier, actually, that you use in your household to recharge the cell phone, that is the charger, that is rectifier. In that rectifier we use filter circuit, capacitor to make the alternating value, this fluctuating value to stabilize. But this is DC current, and this is the DC current of same amplitude, and this is fluctuating amplitude. This is the DC of fluctuating amplitude, and this is the DC of constant amplitude. But this both are DC current. Remember, my dear students. My dear students, which is the very important, the SI unit of alternating current and direct current, AC current and DC current, both are ampere. So it is the very important question how you will distinguish these two, or how you will correlate the SI unit of these two, if it is the AC current or the DC current. It means, will you able to only find the AC or DC with the equation proper, or this will be some concept do we have? Yes, the AC current unit and the DC current unit, the ampere of course, but what should be the correlation between these two? I am leaving this question to think, and you have to think upon it. Symbol, my dear students, what should be the symbol of AC current and DC current? Okay, so look at here, the symbol of AC current and DC current. So the symbol of AC and DC. For AC we use a symbol like this one, alternating. Here the pattern shown inside a circle, this is the symbol of AC. And for DC we use a symbol, even we use to represent the source as DC, like this way, the battery. Okay, the polarity plus and minus in direct current, because the direction not changed, but here the direction changes, that's why we cannot give the positive or negative, but the instantaneous value will have the polarity. If you are talking about the instantaneous current, then you can give the polarity that we will use in electronic circuit. Okay, my dear students. Now let me solve a very simple numerical. If it is given in equation as IT is equals to 10, or you can write here the 5 sine 314 t. Okay, this is given. If the resistance of conductor through which this current is passed is 10 ohm, then find peak value of current and voltage, as well you have to find the frequency of that source through which this current produces in a conductor of resistance 10 ohm. How you will solve? Try to think upon this question. Pause the video and try to solve. Okay, now let me solve, my dear student. We'll compare this equation with the instantaneous value of current, AC current. It is IT is equals to I naught sine omega t. Here you can see this I naught 5 sine 314 t. So this 5 is nothing but the I naught. So the I naught will be 5 ampere. Directly we got the peak value of current. It is 5 ampere. And we know that E naught is equals to I naught times R. Using Ohm's law or So we can write the E naught, it is equals to I naught. We got 5 ampere and the resistance it was 10, so it is 50 volt. This is the voltage. Now for the value of frequency, we know that this is omega. If we will correlate, this will be the omega. It means omega, it is 314, it is given, and we know that this omega is 2 pi f, so it is 314. F will be 314 divided by 2 pi, it is 3.14. all right, and it is cancel out the 100 divided by 2, it is 50 hertz. So these are our two answers, the first one, second one, and the third one. These are the answers. This was the very simple question, my dear students. This type of question you will get in board examination. Now let me move for the next topic. It is average value of quantities. Here we have studied the current and voltage. That's why we will continue with the average value of alternating current and voltage, that is the AC current and voltage average value. Okay, now give the heading average value of AC quantities. Okay, average value of AC quantities. Of course, we are talking about average value of current and voltage. How we used to find the average value we have studied in standard 11. Okay, in the same way we will study here the average value of current and voltage. If this is the alternating current, so you can see here the average value in this full cycle. This is the time 0, this is the time period t by 2, and this is the time t. So in full cycle the average value will be, since this will be positive and this will be equal negative, so average value will be 0. That's why we are going to find here the average value in half cycle. If you will learn how to find the average value in half cycle, then you will be able to calculate in full cycle, and that will be 0. You can verify. But the average value we use to represent any function, the average value, it is represented as that the instantaneous function dt over dt from initial value to final value. It is clearly mentioned in H.T. Verma. It is average value of any function can be written at the instantaneous value of that function ft dt over dt from initial to final, integrating from initial to final. If we are talking about the average value of current, AC current, it means we have to write this I average is equals to IT dt over dt. Of course, this is very simple. And if we talk about the values in half cycle, it means we have to integrate from 0 to t by 2, from 0 to t by 2. Am I right? Yes. Now, my dear students, you have to put the values here. IT, we know that it is I naught sine omega t into dt from 0 to t by 2 divided by dt from 0 to t by 2. This will be t by 2. We will put, so the average value, it will be 2 by t, 2, this one as 2 by t, since it will be t by 2, and I naught will be taken out. We will integrate sine omega t into dt from 0 to t by 2. It is 2 I naught by t. Integration of sine will be the minus cosine omega t over omega. We can take out from 0 to t by 2. We are going to put the values here, the 2 I naught by t omega, okay, and here minus cosine omega, it is 2 pi by t, into the upper limit, it is t by 2, minus plus cos 0. I hope you understand. 2 I naught by t, and this omega can be written as the 2 pi by t. We can write this one, 2 I naught by t omega. Here this t will be cancelled out, 2 will be cancelled, minus cos pi plus cos 0, it is 1. And it can be written as, my dear students, t will be cancelled out and this 2 will be also cancelled out, and it is minus 1, cos pi minus 1, it is the plus 1 and 1, 2, and here 2 I naught by, in denominator we are having pi. So the average value of current over half cycle, it is 2 I naught by pi. I hope you understand. This is not very difficult, my dear students. Okay, so this is the average value of AC over half cycle. In the same way, you can find out the average value of AC over full cycle if you will put the limits from 0 to t and from 0 to t, then you will get this entire value becomes 0, which shows the average value of AC over full cycle, it will be 0. Okay, my dear students. If you will have any question, not very tough, but to find the average one, then you can solve, I'm sure, using this formula. But this particular derivation used to ask in examination to derive. Remember that derive this value, that is the average value of AC over half cycle, full cycle, etc. You need to prove. My dear students, suppose I am giving you here the value of current, instantaneous current as a function of time, then could you find the average value? Yes, you can find. So this will be your homework. This is your homework, my dear students. I am giving you. At the time, current as a function of time, it is given. It is 2t square plus t plus 3 ampere. Find average current in 3 seconds. You have to find the average current in 3 seconds. If the current, instantaneous current as a function of time, is given to t square plus t plus 3. Remember, this t is time, representing the time, alright, in second, and this current is in ampere. Okay, so this is the introduction basically of this chapter, my dear students. We will continue this chapter with the RMS value of current, that is the very important, and we will start in next lecture. Okay, my dear students, so this is all about today's lecture. Thank you very much.